Okay, is everyone set up? Cool, awesome. Sorry for the bit of a long setup, but it's just nice to get everyone on the same page before we start. Otherwise, then it's like the 2-hour coding workshop where you can't code. So everyone, thanks for coming along. It's a good turnout. And hopefully over the duration of this workshop, I can get you as comfortable as possible with Python ahead for your units or whatever you want to do with it. So just a bit of a overview. I guess we'll get started now. So recording started and everything. I'm Nick. I've been learning Python for like 3 or 4 years now. And I work a lot with Python. Just a bit of an overview. This workshop here is Intro to Base Python. So in this workshop, I'll be giving you an overview of the Python landscape, why we care about Python, as well as what's possible in Python. And then we'll be delving into basically the core functionality of Python. How do we work with data? How do we manipulate data? How do we control logic flow, right? And then the next series of the next workshop, which is going to be workshop 2, we'll be going over fundamental scientific computing packages, matplotlib and numpy, and how to use them in mathematical contexts. And I guess with this workshop, it's like, and with both these workshops, there's a limit to how much we can actually cover, right? And because of that, I've made sure to link to as many resources as I can. So if you want to learn about something in particular, you have links to that. So some really good resources here are Kaggle Learn, DataCamp, Coursera, YouTube, Awesome Python, as well as the Python Discord, which is a really good community for learning Python. Just a bit of a disclaimer. This is a 2-hour workshop covering base Python. Just for a bit of context, there is a unit called, there are Intro to Python units, which basically cover, like, we're covering about 60% of that content. Now, I don't expect everyone here to master Python in 2 hours. That isn't the purpose of the workshop. The purpose of the workshop is to give you pretty much like a pretty good foundation in why we care about Python, why is it important for the work that we do, as well as, so that's the purpose of like the workshop components of this. This resource here is more than 2 hours worth of content. So some stuff I'll be glossing over just because it's like, it's a bit listy, if that makes sense. It's like, here are 6 different ways you can do something along these lines. Like, this is how, I guess, like syntax for like greater than or less than or stuff like that. It's listed there. I'll just kind of say, it's there if you need it in future. You can come back to it. And that's the purpose of the table of contents, which might be a bit daunting. But the goal with the workshop really is just to say, here is everything, just so you know that it exists. If you want to use it, you can flick back up to here, Control F through the whole workbook, or look online, and it's there. But of course, the purpose will be having the presentation components as well as a bit of interactive coding. So the purpose of that interactive coding is for you guys to get help if you need. Aria here is one of our tutors, so he'll be helping out. And yeah, and I'll also be walking around as well during the question component. Cool. Before we kind of launch into coding, just ignore the vocabulary section. If you like get confused of a word I'm using, it might be in there. So feel free to read through that if you're interested in that. Let's talk about Python from a macro view and like do a bit of an intro to Jupyter. So why bother with coding? Why do we even care? And this is a bit of a quote from me. Being able to code is being able to have absolute control over your computer to solve any problem that you're interested in. Now, I don't know if you've had a bunch of photos from you and your friends and you want to rename them, maybe like 001, 002, 003, and you have 1,000 of those photos. That's an absolute pain in the ass to do by hand, right? The nice thing with coding is we can get the computer to rename everything for us. So renaming 100,000 photos by hand, that's a 10-day job for a human. It's a 2-second job for a computer. So that's just one example use case. And by the end of this workshop, like that's a pretty easy use case to solve. And then you extend that to the nth degree, which is a lot of us coming from scientific backgrounds, I'd assume. If you're an arts major, welcome. And we're interested in how we can use Python to process our data, whether that be to run simulations, do visualizations, or transform our data. It's pretty much act as Excel on steroids. So that's the beauty of coding, is being able to control the computer to do whatever we can imagine. So yeah, modern computers are amazing. If you're interested in some of the stuff that you can do, Matt Parker, if you know Matt Parker from Stand Up Maths, also former UWA alumni, one of the things he did was simulate a game of Monopoly in Python, and then kind of see which properties are the best to buy. So if you want, you can check that out. So some of the possibilities include automatically editing videos, scraping data from a website, making mathematical animations like 3 Blue 1 Brown. He codes in Python. That's how he does everything he does. Building website servers, data manipulation, yada, 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 the list goes on. So rather than kind of focus on all those different tangents, we're just focusing on base Python to give you the foundation to kind of launch you into any of those things that you want to do. So the programming mindset. When we're programming, it's very much similar to maths. Now, if you're a mathematician, that's probably nice for you. If you don't like maths, then I'm sorry. But coding is 80% about problem solving and 20% about syntax. And I can't emphasize this enough. The ability to boil down a problem into smaller problems and individual steps, individual computational steps, is hands down the most important part of coding. Just like solving a maths problem is breaking down this big problem into a series of mathematical steps, coding is breaking down this large problem into a series of computational steps. Once you break down the problem into individual steps, and this is in your head or on paper, from there you can translate that into Python, and that's where the syntax comes in. But 80% of your time should be spent on paper or in your own head, just thinking about the problem, what are the steps to solve it. If you get this wrong, and I don't blame you, like I have, even after 3 years, I've been looking through, trying to just like get it to work. The problem with that is like, if you're spending like, it's not unheard of to spend 2 hours staring at the screen trying to get it to work. You go for a walk, kind of think about it, and then you go back to the computer and solve it in 2 minutes, right? So sometimes taking a step back, going back to the drawing board is really a step forward. Yeah, I of course can't overstate how important problem solving is to coding. So why do we care about Python in particular? Python is the easy to read, jack of all trades language that is adored by the scientific computing community. So it's one of the top 3 most popular programming languages, besides, I don't know, 2 other languages. And just a bit of emphasis on why Python is easy to read. We have 2 bits of code which do the exact same. We have a bit of C code up there, which is, I mean, you can read through that. I mean, there's a lot of random stuff there, followed by a bit of Python code. So basically what this is it's a loop that goes through a list of integers and just prints out each one. In C, that's like 10 lines. In Python, 2 lines. And the nice thing with the Python code is we have 4 elements in, 1, 2, 3, 4, 5, print out element. And I feel like even if you don't come from a programming background, you can kind of get a sense for what that does. And that's what makes Python really nice, because the easier something is to read, the easier it is to write. The easier it is to write, the quicker you can prototype, right? So that's why Python is loved. And then it kind of becomes like a chicken egg sort of thing, because since Python is so easy to get started with, lots of people start using it, and then lots of people develop tools for it, and then lots of people come to Python for the tools that it has, and it just becomes a snowball effect to the point now where Python is so popular that there's so many packages for it, and packages can be kind of thought of as mods for Python, basically libraries of code that other people have written, and you can kind of slap on top of Python and use those frameworks. We'll be talking more about packages next week, but just a bit of to give you a bit of a sense of like some of the scales of these packages. When we look at numpy, which is the package we'll be covering next week, This is the code base for NumPy. GitHub is just a way for people to collaborate on a code base together. That's all you need to know about that. The main thing, used by 1.1 million people. This is a vast underestimate. I mean, I don't know how GitHub counts this. Wouldn't be surprised if it's over 20 million people, because this is pretty much the foundation of most stuff done in Python. And 1,300 people have contributed to this exact code base, whether that be implementing a huge amount of features or fixing a typo. But yeah, 1,300 people working on a package. You can imagine that if you want to do the stuff that NumPy is good for, using NumPy is probably better than any janky solution that you might have cooked up. So, but that's the nice thing about packages like these, because they've been kind of refined and refined and refined by lots of people looking over the code base. But yeah, we'll talk more about packages next week, where we introduce NumPy matplotlib. In this workshop, we'll just focus on base Python. But before that, let's just talk quickly about the Python pipeline, right? When you write code, you write it in a Python file, right? Just a file sitting on your hard disk. A file ending in .py is for Python scripts. These are just text files that run from top to bottom. Or alternatively, they can be written in .ipynb files. These are the files we're dealing with today. It stands for IPython Interactive Notebooks, and we'll discuss this more when we talk about Jupyter. To see and edit file extensions, you might need to update your settings accordingly. There's instructions there for Windows and Mac. But once you enable file extensions, you'll be able to kind of see which file types you're dealing with. The program used to, so those are the files. The program that you use to actually write your code is called your IDE, Interactive Development Environment. Now, you can write text in, you can write your code in Microsoft Word, right? Microsoft Word is an IDE. Technically speaking, it's a really bad one because it's not meant for coding. So is Notepad. Notepad's an IDE. Really bad IDEs. Good IDEs normally have a run code button. Yeah, so in terms of IDEs, VS Code, if you've heard, VS Code is a really good IDE. The IDE we'll be using is Jupyter. So that's how we'll be running these IPython notebooks that end in IPynb. So Jupyter is specifically suited to running those. Yeah, and when we run a Python script, which isn't really the focus of this workshop, we pass the file to an interpreter, which runs the code in the terminal. Yeah, and good IDEs normally have a run code button at the top. Let's just talk a bit about Jupyter. So there are different IDEs we can use to edit IPython notebooks. In Workshop 0, we went through some of these. Some are Jupyter Lab, Jupyter Notebook, which is what I'm using right now. Google Colab, which if you haven't got a local install, you'll be using. So if you just go to Google Drive, more Google Collaboratory, you should see that. And VS Code's an option. And then we've all gone set up with Anaconda, so that's fine. If you're still yet to launch Jupyter, please just raise your hand and I'll come around. Sorry. Okay, so let's get started with our first notebook. Any questions so far? No? Okay, cool. Yeah, let's get started with our first notebook. If you are in this sort of window here, you can just do new, Python 3, notebook. And that will spin you up a new notebook. If you're able to have both this notebook up in one tab and your own kind of sandbox notebook up in another tab, it's a nice way to learn. You can kind of just freestyle in your other notebook and then without messing up my beautiful notebook. Cool. So a notebook consists of a sequence of cells. Cells can be kind of thought of as blocks, right? Now, with Jupyter, it's a bit different to normal .py files. With Python script files, the interpreter runs them from top to bottom. And it's just code. It's only code. With IPython notebooks, it's interactive. hence interactive Python, where you can run cells in whichever order you want. So Python's pretty much sitting there, and we're throwing it cells to execute on the fly, right? So I can run a code cell at the bottom of my notebook, then one at the top, and I can intersperse them. This has its quirks, meaning that it kind of remembers what you previously ran, even if that cell doesn't exist in the notebook anymore. And because of that, you might need to restart your kernel every once in a while just to kind of wipe its memory so that it starts again. But we'll cover that a bit more. At the moment, let's look at navigating cells. So let me quickly just spin up a new notebook here. OK, so if you have a blank notebook, this is what you'll see. We start with a code cell, right? There's two different types of focuses. At the moment, it's highlighted green. If you're in Google Colab, it'll look a bit different. But at the moment, it's highlighted green. If we press escape, highlighted blue. So this is the difference between, this is the command view, and then this is the cell view when we're editing inside the cell. Of course, if we type anything we want, it appears in the cell. If we press escape, we can actually use some keyboard shortcuts to add new cells, right? If I press A, that'll add a new cell above. I can spam that. If I press B, that will add a new cell below. And if I want to delete a cell, I can press double D, and so on. I can also select cells by doing Shift up, and then delete them all at once. Some of the shortcuts are listed there. If we do help, keyboard shortcuts, there's a lot more shortcuts in there. So using shortcuts, I mean, you can also use the GUI up here. I want to add some new cells. You know, you can use arrow keys to navigate. I think the thing is just trying to avoid using the buttons up top, just because, like, if your hands are already on the keyboard, it's just easier, quicker to just use the keyboard commands. So I'm just quickly going to, if we want to run a cell, the way that we can do that, another thing is there's two different types of cells. So we have our coding cells, but the really nice thing about Jupyter Notebook is that we can intersperse code with paragraphs and equations and tables. So the code is written in code cells that look like that. If we press M, it converts it to a markdown cell. And markdown is how we can literally just write any sort of text. And if you actually double click into this cell, this is a markdown cell. So this is how I was able to format these titles, these links. So pretty much, like, if you're curious about how I did anything in this notebook, you can just double click in it, and it'll show you exactly what I typed in order to get that. Okay? And that's a really nice thing about Jupyter, because since you can intersperse paragraphs, equations, and then all that sort of stuff, since you can intersperse them, it means that if you do an analysis, you can just send it over to your colleague. They can run it top to bottom, kind of see exactly what you did and see your explanations along the way. Whereas with normal Python script files, you can't really do that. Cool. Yep, so just a bit also here about Jupyter's memory. So if I do x equals 2, and we'll cover a bit more on this just now, but if we print out x, it'll show 2. But if we delete the cell, x is still 2. And that's this idea of Jupyter remembering what you previously executed, right? The way to kind of reset that is to click kernel, restart and run all. If we actually just delete this because this isn't valid. It says x is not defined now because you've kind of refreshed Jupyter's memory, and then it doesn't have this recollection of x. Cool. Awesome. And then we can also convert between code cells and markdown cells by using those shortcuts, M and Y to convert back to code. Awesome. Cool. That's, I guess, a bit of the groundwork of Jupyter. Jupyter is really nice. It just makes it really easy to prototype as well, because since you can kind of disconnect this idea like different code blocks, it means that if you have a simulation that you run, takes 30 minutes, and then you want to like plot out your simulation results, the way, like if you're writing that in a .python file, you'd run it top to bottom, and if you got the title of your plot wrong, you have to run your whole simulation again, right? The nice thing about Jupyter Notebook is it kind of disconnects that, and you can run your simulation, then you can like tweak your plot and kind of get your exact title, your exact axes. Awesome. Okay, when we think of coding in general, there are basically 3 types of operations we can do. We can either manipulate data, we can either store that data to be used later in the program, or we can control the logic flow of the program, right? So, and if you think about it, that pretty much encompasses everything to do with coding, right? We're either doing something with data, we're either storing it for later, or we're controlling logic flow. The last point is particularly important for writing good code. Because, to be honest, we don't even need this third one. If you want to add 1 to a number like 100 times, you just have to repeat that line of code 100 times, right? But the thing with writing good code is non-repetitive code. Code that, if you're copying and pasting lines a lot of times, that's bad code. And the reason for that is, as soon as you start copying and pasting, and then down the line you want to change that code, if, say, I've copied and pasted that line 100 times, I have to change that line of code in 100 places. Now, what happens if I've forgotten to change it in one of those 100 places? It just becomes very difficult to manage. So with Python, there's lots of tools that we have for allowing us to control the logic flow of our code, and we'll go through that a bit later in the workshop. But once we're able to control logic flow, it just makes it much easier to write good code. Cool. Okay. Let's just talk about what data types there are in Python. There are 15. Some of them aren't really used much, so I list 10 here. I'm not really going to talk in detail about each of these individually because we'll cover them as we go. But there's integers, floats, complex. So floats can be thought of as decimals. It's just decimal numbers. Complex numbers, which we use J for, engineers anyway. We have strings, which is for text data. So whenever you hear the word string, that's just referring to text information. We have lists, which can be used to house a combination of numeric and string types and even other lists within that. So just sequences, pretty much. Tuples, similar to lists. We don't really cover it in this workshop, but there's some nuanced differences, but we're just not going to cover it. That's fine. We have range, which is a really good object for generating sequences of numbers. So, and we'll cover that as well a bit later in the workshop. We have booleans, which true or false. That's it. Booleans are really helpful. Anyway, so the way that you specify a boolean is just by writing true or false. We have a none type, which is basically kind of equivalent to undefined, right? So if you have something that doesn't really return anything, it just returns none by default. It's kind of like a nothing data type, just kind of exists in its own category. And then we also have mappings like dictionaries. It's kind of different to a sequence. A sequence is kind of like ordered. Mappings is kind of like, hey, John has a name, John has an age. We don't really talk about dictionaries, but super handy if you want to learn them, but I mean, we don't really cover it. There's a bit of special stuff with strings. You can read that if you want. I'm just going to skip over it because we have quite a lot here anyway. Basically, if you see some weird \n's, \t's in strings, that kind of explains what's up with that. As seen here as well, any line that starts with a hashtag, that is a comment. This allows you to basically write anything in your code that you want. Also, basically, as soon as Python sees a hashtag, anything beyond it is a comment as well. This is just nice for you to be able to tell whoever's reading your code what you're doing. It's good practice as well. Like, I mean, you don't have to, if you're adding 1 to a number, I mean, a useless comment would be adding 1 to a number, right? Because, I mean, whoever's reading that code will be able to see what you're doing. But if maybe your comment is incrementing the counter for the next iteration of the loop, or something along those lines, or maybe, like, I guess when you write comments, you can try write informative comments and kind of give us an idea of the context and why you're doing something. Whether you write comments, that's up to you. Yeah, anyway. Cool. Our first program, print hello world. This is, in order to run these cells, by the way, if you like click into them, you can just click the little play button up here, or you can do shift and enter, and that runs that cell. Hello world. Print, what that does is it basically displays the output below the Jupyter cell. Okay? So whatever inside, whatever that evaluates to. Also, sometimes we might, when we're dealing with variables, we might forget what type they are. Like if we just want to check what type they are, what we can do is we can do type of hello. So if we wrap hello around type, we can see it's of class string, str. If we say x is 2, we can see type of x is integer. And if we put 2.0, we can see it's now of type float. So just a couple cells there. So that's your first code. Well done. And yeah, so let's talk quickly about assigning variables. I think this is a bit of a stumbling block for especially you mathematicians out there. The equal sign does not mean equals. It means assign. What is the difference? Well, the assign operator, the equal sign, is basically saying whatever's on the right-hand side of it, I want to store that into the variable name on the left, right? Now, with coding, we can use anything as a variable name. We can type whatever we want, and we can store that for later use. So if I want to, so what's on the right is evaluated and then stored into the left. So beware mathematicians, equals the equal sign means assign and not equals. The difference is if we do 2 equals x plus 1. As mathematicians, we're like, oh yeah, x is 1, because that's the solution to that equation. But with Python, it looks at the right-hand side, and it says x plus 1. I haven't heard about x. I don't know what that is. And I mean, like 2 is a number. I can't assign into that. So that's just something to be aware of, that Python doesn't rearrange your equations for you. That's still your job. And if you want to, and yeah, that's pretty much that. So here we just practicing a bit with assigning. And I guess wait. Oh yeah, we'll cover that just now. So here we just have some assigning. We're assigning 1 into x. Hello there, Bob, into my string. Now this right-hand side, that gets evaluated. So that evaluates to 0, 1, hello there, Bob, and assigns that into my list. So if we actually print this out, we get 1, hello there, Bob, a list containing 0, 1, and hello there, Bob. And then we're adding 1 to x and printing out 2. So x evaluates, x plus 1 is 2, and that's stored back into x. And then we print out x. So what about the following? What if we say x is 1, y equals x, and then we say x equals x plus 1. If you see x equals x plus 1, that looks kind of weird from a mathematician's point of view, right? Because x can never be equal to x plus 1. But that goes back to that equal sign meaning assign and not equals. So what we're doing here is we're just adding 1 to x and shoving it back into x. When we run this code here, we say x equals 1, y equals x equals x plus 1. If we print out x and y, we see that x has increased, but y has remained the same. And what that is saying is when we say y equals x, the right-hand side is evaluated and then stored in for y. So it's not necessarily that y is linked now to x. It's just that x at that moment was 1, and that's stored into y. So whenever you want to update a variable, you need to explicitly assign into it. You basically need to tell Python, hey, this variable is now this, remember? And we'll get back to that, okay? Awesome. Rules for variable names. What can we use as a variable name? A variable name, so there's about like 3 different categories there's 3 different rules, I guess. We have to obey the syntax. We have to use the right characters. We can't just start a variable name with a hashtag, because remember, that's our comment character, right? So those are the rules. A variable name must start with a letter or the underscore character. A variable name cannot start with a number. It can have numbers anywhere else, but just not at the beginning. A variable name must contain alphanumeric characters, the case sensitive, yada, yada, yada. There's a list of keywords that are reserved by Python that we can't use as variable names. If we try use these keywords as variable names, Python will just say, hey, yeah, can't do that. So an example of that is something like true. We can't say true equals 2 because we can't assign to that, because that's a reserved keyword. If you click in here, look at that. Got a nice list of reserved keywords for you not to use as variable names. Okay? You don't really need to understand what all of these do, but I mean, if you try store a variable name into, say, class, that won't work. Okay? And then there's a so we need to use valid characters in our names. We need to avoid reserved keywords. And then there's a third rule, which is slightly more nuanced, which is built-in functions. In Python, there are some functions which are just kind of like built-in. They kind of come with stock standard Python. Now, we shouldn't be assigning variables into those function names. And one example of which is print. What if we did print equals 2? Remember, print was our print function. We just use that to print out hello world. Now, will this run? Yes, it will. But now, now every time we type print, it'll be equal to 2, right? So you can imagine if you actually, so what we've done here is, since we've used the built-in function name as a variable name, we've pretty much overwritten it. Python has kind of forgotten what print does, and now print is equal to 2. So now if you try doing something like this, Python's like, I have no idea what you're talking about. Print is an integer. The equivalent, I guess the equivalent to what you just did was that, and that's not valid Python. So if you do something like that, the way that you reset it is just by going kernel, restart your kernel, and that'll tell Python, hey, forget all of that. Let's start afresh. Awesome. If you run this, we have some valid variable names, and then we have some examples of invalid variable names. Now, types. We can convert between types. Sometimes we have a string that we want to convert to a number, right? So that's a float. That's a string at the moment, but we can convert that to a float. And then we can also add, once we have items in the correct type, we can add them together and operate with them. So if we have 1 plus 1.1, integer plus float, Python will kind of be like, yep, that sounds good. 2 numbers, I can add those. OK. Just a bit about reading the traceback. Whenever you get an error like this, don't be scared. You just, it's pretty, I feel like it's, like if you read the error, it's pretty, it's pretty understandable what it means. We have on our third line, we have 1 plus 1.1, and it basically says unsupported operand plus between int and string, which basically means that, hey, you can't add a number and a string together. I feel like that's pretty self-explanatory if you just read the traceback. It's a skill that you develop. Cool. Data manipulation. How do we manipulate data? So we've just covered how to store data. How do we manipulate it? Bunch of mathematical operations we can do. I'll let you read that. But just a note that we do not use a caret symbol for to the power. It's a bit of a stumbling block for a lot of people, including me, when I first started out. It's double asterisk. So if you want to do 2 to the power of 2, you have to do 2 asterisk asterisk 2. Okay? Don't worry, you will forget, and Python will shout at you. Got some examples of using the operators there. We also have some mathematical functions built into Python. We have minimum, maximum, so that's if you have a list of numbers, you can just chuck minimum around there and it finds a minimum of that. Maximum, round, absolute, and the power function, which we can also use double asterisks. The great thing about Python is if we don't know how to use a function, we can just call help on that function name, right? So if I execute the cell help round, that will return the string, the help string, and I can print that out, which will basically give me documentation on how to use the round function, right? This is the same with every function in Python, right? So getting used to reading this help documentation, really handy. Even for packages, the help documentation is there. So you don't have to go Googling, it's just right there. The nice thing about Jupyter, if you press Shift and Tab, that'll also bring up the help documentation, right? So if you're inside a function, like so, just Shift Tab while your cursor's inside, it'll tell you exactly how to use that function. Okay, so just Shift Tab, very handy. And then Tab can be also used for autocomplete. So if you really want, you can just press Tab, and when there's different options, like it'll bring up a list like so. Awesome. Mathematical operations for strings and lists. We can also use mathematical operations if we want to work with strings and lists. If we add 2 strings together, it'll stick them together. If we multiply a string by an integer, it'll repeat that string 10 times, 5 times, whatever the integer is. And we can also add lists together. When we add lists together, if you have a list of 1, 2, 3, and another list of 1, 2, 3, and you add them together, actually this example, 1, 2, 3, 4, 5, 6, right? If we add those together, you might be thinking, oh, those are vectors, 5, 7, 9, right? Unfortunately not. It just sticks those lists together, slaps them end to end. Now, the thing is with lists is there's no real the thing about base Python, there's no real concept of matrices and vectors, unfortunately. If you want to add things element-wise together, you have to go element by element and add them together. And that is where the logic flow comes in at in the next section, like kind of iterating through that one by one. The next section we'll go through, numpy. Numpy adds the ability for us to kind of just say, x is a vector, y is a vector, add them together. Right? NumPy is super powerful, allows us to do that sort of stuff. But yeah, not in base Python, so if you're trying to add vectors together, just make sure that you're like going through each element and adding those together and forming the updated vector. So no vector-like or matrix-like data structures in base Python. Okay, so at the beginning section of this workshop is like quite a bit of content, so I'm sorry if I'm talking a lot, but we have now comparison, logical, and membership operators. Basically in Python, sometimes we're interested in like looking at a variable and like seeing, okay, what is that variable, right? Maybe we're interested in this number x, and we want to say, is x an even number, right? So if we wanted to see if x was an even number, what we can do is take x modulo 2. If x modulo 2, which is basically saying what is the remainder after we divide x by 2, if x modulo 2 is 0, then we know that's an even number. If it's 1, we know it's an odd number. Now, the way that we determine whether it's 1 or 0 is we use the double equal sign. Now, the double equal sign, it does mean equals. So there we go. But this, it still won't rearrange for you. This will just tell you true or false whether it's actually the left is equal to the right. Okay? So it won't actually do any rearranging. So if you have x and y defined, and x is equal to y, and you do x equals y, the way Python will interpret that is it will evaluate that, and the result of that will either evaluate to true or false. And that's actually the truth for comparison, logical, and membership operators. So all of these operators here, comparison is for comparing two things. And it's seeing whether they're equal to each other, whether they're greater than, whether x is less than y, it'll evaluate to true or false. And the nice thing with that is we can actually then make decisions in our program based on the values of numbers. If x is greater than this, we can run this piece of code. If it's not, then we run this other piece of code. And this here will tie into logic flow, which we'll cover just now. So there's a list of different ways we can compare variables. There's also different ways we can combine variables. So sometimes we're interested in whether is x equal to 1 and y equals 1, right? In that case, x equals 1, that's a comparison operator. But the logical operators is how we can combine two Boolean values, right? So and then you can read through that. So combining two Boolean values, we can either use the and or not. So not negates the Boolean, or basically says if any of bool 1 and bool 2 are true, then the or makes it true. If both of them are false, then the or operation is false, and then and, pretty self-explanatory. Okay. So all these, and then we also have the third one, which is membership, which basically is looking at whether an item exists in a sequence, right? So sequence is a list. If we're interested in whether 2 is in that list, then we can say item in list, and then we can look at that. The best way to learn is through examples. So if we run that, we can see exactly what's happening. So this here is just a string basically telling you like what this means. And that is actually like when we print this out, this will be evaluated, right? So we can see x equals y. Well, x and y are 1 and 5. So x is not equal to y. So x equals y is false. X not equal y, that's true. And so on and so forth. X is in my list, x is 1, my list is 1, 2, 3, x is in my list. X in my list is true. Okay? Cool. I'll just let you read through that. This is also just like, you guys have this notebook, so you can also read back after. Okay, logical flow. Okay, from what we've learned so far, we can pretty much write a lot of code. We can do a lot of things, right? It might not seem like it, but we can actually do quite a lot of things. But the problem is, at the moment, is that any code that we write, it runs from top to bottom, right? There's no way for us to actually control the flow of the execution. It runs from top to bottom, executing every single line exactly once, right? Now, and there's also no way for us to run code based on the internal state of the code, right? There's no way for us to say, run this piece of code if x is 2, or run this piece of code if x is 4, right? What we're missing is one vital piece of the puzzle, and that is logic flow. Now, we have different options for logical flow. We have if-else statements. And if-else statements can be kind of thought of as like a decision tree, right? So you can kind of, if like x is greater than 1, we can do this. If x is less than 1, we can do that. And we can kind of construct these decision trees. For loops, while loops, try except, which we don't cover in these workshops. But if you want, you can click through that link and learn more about it. And functions. So we'll go through those 4 different ways of controlling logic flow. So if-else statements, they're basically used to, if statements are used to execute some code if only a condition is met, right? So if this condition is met, it will go into this code block and it will run whatever code is there. Now, if you just look at this, you'll notice some interesting things about that code block. First of all, the line after if condition is indented by 4 spaces or a tab. If you're on Google Colab, you might need to go into settings. I think by default, it indents it by 2 spaces. Anyway. Cool. So it's indented by 4 spaces. Normally, can be 2 spaces, as long as you're consistent. But 4 spaces or a tab. This indented code is called an indented block. And says, and basically, when we indent this code, we're telling Python that everything in this indented block is part of that if statement. If something's out of that indented block, as in if we de-indent it, then it's outside that if statement. Okay? So if we say if x equals 2, and we want to run a specific block of code, we just need to make sure all the code that we want to run, if only x is 2, we just put in that block. This is different to some other languages where indentation doesn't matter at all, and the way that they specify blocks of code is by wrapping the whole thing in curly braces. Now, you'll also notice if condition that ends with a colon. What that colon tells Python is, hey, there's going to be an indented block in the next line. Just heads up, indented block next line. Okay? And that's also a good cue for you, that if you see a line ending in a colon, that it works with blocks, right? And all of these logical flow things, they work off blocks. So if we have an if statement, there is code relevant to that if statement. If we have a for loop, there is code relevant to that for loop, and so on. If we have a function, there is code within that function, so we use an indented block. Okay? So, so that's if statements. We also have an else clause here. So if that condition is met, we can run this code, and then we can have the else clause, which is directly after that if statement. And this is also optional. Sometimes if x is 2, we do this, but we don't really care if x is not 2. But if we do care if x isn't 2, we can run some other code there as well. So that's the syntax there. Extra reading. Along this workshop, we'll have a couple extra reading, just links. This is stuff that I deemed wasn't important, just because there's a lot of stuff. But extra reading if you care about it. If you don't, you're not really missing out on too much. So yeah, nice to know, but not necessary. elif statements. It just basically shortens some stuff. So here we're looking at x. Here we have an example piece of code. X equals 1. If x modulo 2 is 0, now x modulo 2 is 0, remember that's how we check if a number is even. Then we print out x is even. Else, we print out x is odd. And then we have this print statement here, which will be executed regardless of the condition, because it is outside of both the if and the else statement, just tucked away to the side. Now, if we have an if statement and an else statement, it doesn't make sense to us for us to put any code in between an if and an else statement, because if and else kind of can be thought of as one unit together. Okay? If we try put code in between, Python is not going to like that. Invalid syntax. But if we take that out, there we go. Also, just a quick note as well. If you want to quickly comment out a line, say you have a block of code that you aren't really interested in, and like say you want a block of code that you don't want to execute, what you can do, highlight all of it, Control/, which is the question mark key, and that comments out all your code. Pretty handy, means that you don't have to go through and like add hashtags at the beginning of all your code. Very nice. And of course, we can change this number up here, and that actually changes what is printed out, because now if x, since x is even now, this top statement, this if statement will execute instead of the else statement. Cool. So that's pretty much it on if and else. You can pretty much construct any sort of decision tree you want. This, if we imagine like diagrammatically, is just there's just one fork in the tree that just branches out. But if you can imagine that if you nested these if statements, if say I did something like this, I can say if x is 2, and then if x is 0, say x is 0, or something like that. So if I did something like this, what happens is x is 2, which is even, so it enters this block and prints out x is even. Then it looks at this another if-else statement and says x is 0. Well, x is not 0, so it prints out x is not 0. Okay. So we can nest these as much as we want. Sometimes we just don't want to nest things too far, but because it gets a bit clunky to read sometimes. I'd recommend also leveraging the other logical structures, which we'll cover just now. Cool. Loops. Sometimes we want to write code that executes multiple times, right? So say we have, trying to think of an example of the fly, can't really think of one. But sometimes we want to execute a bunch of code multiple times. I guess in the example of the renaming photos example I mentioned at the beginning of the workshop, you can imagine that we'd want to rename every single file in that folder. So we want to execute the same block of code for every file. So we'll want to do that multiple times. Okay. So to do that, there's two different types of loops we can use. We can use a for loop. This is the most common form of loop, where we have a block of code that repeats a predetermined amount of times. This basically means at the beginning of a loop, we know how many times it's going to execute, right? Because in the example of the amount of files in the folder, like we look in that folder and we're like, oh, there's 1,000 files there. I guess we're going to rename 1,000 files. And then you start the loop. There's also a while loop, which we'll cover just now, which is when we don't know how many times we want to execute that loop. So the syntax for that is for item and iterable. Iterable just means anything that has the concept of a beginning and an end. So pretty much like a sequence. So a list is an iterable because a list is a sequence of list elements. A string is an iterable because a string is a sequence of characters. The range object is an iterable because it is a sequence of numbers from a starting point to an end point. Range, super handy for loops, and that is the principal function to help with for loops. So let's dive into an example. Hey there, this is a list of words. Loop count equals 1 for word in my list, which is this list of words. We're going to print out the loop count, followed by a colon, followed by the word. Now, the way that for loops work is we have for item in iterable. What happens is so once this for loop starts, the first element, hey, is assigned into word and then is run with that loop. That loop is run with word assigned as hey. Okay? So as we see here, we have loop count starting at 1, and then we have 1 colon hey. And then what we do is we say loop count, I want you to be 1 more. So we say loop count plus 1, which is 2, and we assign that back into loop count. And then it goes back to the top and says, okay, we're done with hey. Let's assign the next word, which is there, and it repeats that loop until it reaches the end, and then it reaches the end of that loop, and then for loop is done, move on. Okay? Hopefully that makes sense. The code's there if you want to play around with it. When a for loop, yes, I've just covered that. The range object. The range object is pretty nice. Basically, it generates a sequence from 0 up until n minus 1. So basically, so if we put range of 10, it's going to generate a sequence from 0 to 10, which is closed on the left and open on the right. What that basically means is that it's going to include 0, all the numbers up until 10, but it won't actually include 10 in that. So if we print out range of 10, we get 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Cool. If you want to look at how we can print ranges, it's up there. We have to do a little bit of a workaround, but that is up there if you want to look at how we can print ranges and look directly into there. So we have a bit of an example there. Hey mom, I can count to 5, 0, 1, 2, 3, 4, 5. Cool. The range object is actually more versatile than that though, because what we did there is we specified an ending point. There's actually 3 ways we can use the range object. We can specify an end-point in which the beginning point will default to 0. We can specify a beginning and an end-point, or we can specify a beginning, end-point, and a step size. So by default, it's going to step by 1 each time, but we can also say, hey, I want you to skip every number, and we can specify a step size of 2. We can also specify a negative step size and say, hey, I want you to count backwards this time. But if we're counting backwards, then the start will be at 10, and the stop will be at 1, and then we can count a negative 1. And then the same conventions arise as well. If we want help on the range function, we click into the range function, Shift-Tab, look at that. Some handy-dandy help documentation right there. Now, sometimes reading help documentation is a bit of a skill. Sometimes you'll see like args and quargs and stuff, some stuff that just looks a bit weird. It's kind of like a bit of advanced usage, I guess. But the nice thing with being, just get familiar with reading help documentation. I think it's a good skill to have. Otherwise, it's a lot of Googling, and you just, it's pretty difficult in that sense. So we have a bit of an example there. We're just summing the squares of the first n integers. And I'm not going, you can read through this code yourself, but basically, if we run this, we can see that the sum of the first 100 perfect squares is 338,350. So I think that's the first example of code that we've, I mean, if you try to do that by hand, I mean, you can chuck an extra couple zeros onto n, right? Calculating the first 10,000 perfect squares is a bit of a mind-numbing calculation, but Python handles it in its stride. Extra reading if you want, enumerate and zip, nice to know, makes for loops more versatile, not important for us. While loops, I'll just pretty much gloss over, but pretty much while loops will execute for as long as a condition is met, right? So if x is 10, while x is greater than 1, it'll execute this loop. As soon as x is not greater than 1, it'll stop that loop. The important thing with while loops is it's a bit more dangerous to some extent. I mean, dangerous is a strong word. It depends what you're doing. But you just want to make sure that whatever your condition is, that it eventually stops, right? Because we don't code that runs forever. We really want code that runs forever. So if you imagine instead of having that condition that x is greater than 1, we had a condition that while x is not equal to 5, right? Now, that works, but if x started at 9.9, for example, and we're subtracting 1 off, it's never going to be equal to 5. It's going to actually skip it. So what we're actually doing with this while statement is it's only going to evaluate to false and exit out that loop, like for one single value, and that value might not actually be hidden. So just when you're using while loops, just make sure that they eventually stop. Okay, so sometimes we want to actually stop a loop or kind of control a bit of how a loop works inside, right? So say we get halfway through an iteration of a loop and we're actually like, I want to break the loop right here. We can use continue and break, right? So this example, I feel like, is a pretty good way of just illustrating it. If I equals 3, I want to continue the loop. What continue does is it kicks it back to the top. It kicks the, I guess, Python interpreter. It's going to go back to the top of the loop. If I hit the break statement, it's going to exit that loop prematurely, and it's going to continue with the rest of it. So if we see that the current number, so if we just follow the execution of this loop, range 10 generates the numbers from 0 to 9, and then it stores that in for I, and it prints out the current number is I. So at the moment, the current number is 0, 1, 2. It's going to skip this iteration when I equals 3, so it doesn't actually get down here to print out what the current number is. And then 4, 5, 6, 7. At 7, it breaks the loop, and the loop is done. So it didn't even get to 8 and 9. How are we going for time? Sorry.
It's like 5:15.
Oh, shit. Oh, okay. So I realize that this is a bit dense, but we'll get on to examples just now. And even if we don't get to finish everything, I mean, it's right there as well. The workbook is, I feel like, a pretty good resource for you to just follow through as well. Functions, I guess this is one of the most powerful parts of logic flow. This is how we can package, because at the moment, if we look at when we're repeating code, for loops means that code needs to be repeated back to back, right? But if you imagine we're calculating the area of a circle, I mean, we might calculate the area of the circle at the beginning of our script and the end. It doesn't really make sense to do it back to back, right? Now, the way that what we can do is we can use functions. So sometimes we want to package together a block of code and reuse it multiple times. The way that we can do that is using a function. So that's a syntax, def my function. So my function is the function name. You can use any valid parameter name you want, any valid variable name, as we were discussing at the beginning of the workshop. And then we open bracket and we can list a bunch of parameters. Now, sometimes we don't want to list any parameters. Maybe our function is just to print out hi there, you know? In that case, where we have my function over here, instead of having parameter 1 and parameter 2, we'll just close the bracket straight after we open it and then put the colon. So that's the syntax. We have my function, function code, return out object, right? So in this example here, we have define the circle area, and then what we're doing here is we're saying if r is less than 0, return the radius can't be less than 0. And yeah, we have a bit of an example there. I'm just going to highlight some important parts above here. This example is a bit like it's a bit more complicated than it needs to be, and that was a bit intentional. Basically, we could boil down this function to something like this if we really wanted to. Right? Where it just takes an r, it returns 3.14 times r squared. But the intention with this up here is to highlight some important features with functions. We can return early, so as soon as it hits that return statement, it doesn't actually execute whatever's below here. It basically returns that to whatever called the function, right? And when we have this function definition, it's the point of the definition is to tell Python, hey, whenever you see this variable name, circle area, I want you to associate that with this block of code. That's all that this function definition is doing. It's just telling Python, hey, heads up, circle area. If you ever see this like further down in like the code, just remember to execute this block of code, right? So when we actually execute here, we have circle radius. Here we're actually calling the function. So whereas above we're defining the function, here we've called the function. And when we call the function, it puts radius in for r. So we'll cover this a little just now, and then we'll actually get onto the pizza and the examples. But when we call this function with radius, it gets slotted in for here. And in the world of this function, it's called r. And then the code is run. And then this getPy function, then it actually looks at this block, this definition, which just returns the number 3.14, whatever, and it executes that line. Okay? So you might be a bit confused as, okay, wait, getPy is called before the getPy is defined. But the thing is with Python is like we don't care that is the case. Pretty much when we executed this, we weren't actually running any code. We're just telling Python, hey, just remember this block of code. Since this getPy function since we're actually only calling this code after we've defined these functions, it doesn't matter that getPy is called up here but defined here, because by the time we reach down here, we've defined both functions and it's accessible to Python. Okay. Now, I'm going to go through something now which is, okay, well, the idea of this circle area R, does that mean, like, can I use R as a variable name elsewhere in my code? Is it going to like clash with the function name? And like, basically, what's up with variables? Because if I have a lot of functions and I'm using like list as a variable name in that function, is that going to clash with the other times I've used list? What we're going to cover here is the idea of scope. And the best way is just to kind of think of this diagram. Now, when we have a function, all the variables that we define within this function, here, this R variable, as soon as that function completes, that R variable is destroyed. We're done with R, we don't care about it, it's gone, Python forgets about it, okay? So that's the importance of local scope. Local scope is the scope within a function, right? It is the variables that you define within that function. So there's 4 types of scope. There's local scope, enclosing scope. Enclosing scope isn't really that important, so I'm just going to gloss over that, because it's rare that we define functions within functions. So we have local scope, global scope, which is kind of when you just have no function, it's just lying out there. And we have built-in scope. Now, if we're in local scope, we can access everything in built-in, global, and enclosing scope. But local scope takes priority, right? So if I have something like this, R equals 2, def my function, R equals 3, print R, and I call this function. R is 2, my function says R is 3, so when I call my function, it's going to say, okay, R is 3, because the local scope takes priority. Although Python, so basically, local scope, Python looks at that first and says, okay, is there a variable called R in local scope? Yes, R is 3. As soon as we take this out of local scope, R is now 2. Because Python looked at local scope, okay, can't find R. Let's go to global scope. Let's see if it's there. R is there, cool, it's there. And then, if it can't find it in global scope, for the example of like print, it'll then look at your built-ins and say, is anything there? And if there's nothing there, then Python will actually raise an error. And if we, of course, if we comment this out, Jupyter kind of has a memory of what we executed before, so R would still be 2, but anyway. So that's the issue of scope. This means, since we have, hopefully that provides a bit of insight, because that means that as long as we define the variable within our function, we don't need to really worry about it, because if, say, we define list to be the input parameter, it's not going to refer to any other sorts of lists that we've defined elsewhere, because in our local scope, we've defined list, so Python will first look to our local scope, and then before it does anything else. So local scope takes priority, meaning that we can reuse variable names. Okay. And I talk a bit more about that. Bit of extra readings, time for some practice, but actually, let's have some pizza first. We have a bunch of questions here, mainly curated by Lucas, so thank you, Lucas, who isn't here at the moment. But so we have a bunch of different questions here as well. And what I'd like you to focus on when doing these questions is to think of the programming mindset, this idea of problem solving, right? If you imagine that if I want to calculate the 4th Fibonacci number, Now, if you know the Fibonacci numbers, that's pretty much 0 and 1, and then you add the last two numbers to get to the next one. If I was to do that by hand, I mean, we'd just see, okay, 0 and 1, 0 and 1, 1, 1, 1, 2. Okay, fourth Fibonacci is 2, right? If you just imagine doing these problems by hand, sometimes like doing it by hand is not that different to doing it by code, right? You can imagine that if someone asks you what's the first Fibonacci number, you just say 0. So you can just code that up. If the n Fibonacci number they're asking for is 1, just tell them 0, return 0. If it's 2, return 1. If it's 3, oh, okay, then we need to add these numbers, right? So just kind of thinking of things that way really helps with kind of designing these solutions. Even something like calculating, if we have a list of circle radii, calculating the sum of the circle areas, if we were to do that by hand, we'd go through each element, right? What's a way that we can go through each element in Python? For loop. Just going through each element in a list. And we need to kind of keep account of the total, right? Why don't we kind of set a variable to be 0 at the beginning? So before the for loop even starts, we say total is 0. Then we do our for loop. Okay? So hopefully that helps a little bit with the programming mindset. It's definitely the best way to learn Python is through practice. So just practice, practice, practice. The more you practice, the better you'll get. And eventually you can start editing YouTube videos with your Python scripts. Awesome. Cool. And I mean, I'm not even joking, by the way. At the bottom, if you want, is a bit of a shameless plug. If you click there, this is a video I made with Python. Oh, should I mute it? Maybe. Anyway, I'll just let that play. Should we dish the pizzas out? There is a bit more to the workshop, but I also do understand that, I guess there's two options we can do. We can either go through some practice, or I can talk a bit more about what the next topic is kind of looking at modules. And this is like modules kind of being kind of ways of like extending the functionality of base Python. Now, it's completely up to you. Maybe you're just like, actually, I just want to get some practice in. Let's do some coding. Or maybe, because I mean, this is also pretty, like you can pretty much just read this by yourself if you want. But I mean, it's completely up to you. What do we think? Practice or more Python?
Yeah, practice.
Practice? Cool. Awesome. I speak for everyone. No, that's good. Okay, awesome. Yeah, I think that's pretty self-explanatory. I think that I'll just like point you quickly to this thing. The nice thing about like using other these sort of packages and stuff, like there's this thing called TQDM, and I just like it's really nice because it turns any for loop into a progress bar. Which, if you imagine that you're doing like this, like doing this in Python, like the way that I would do this before is like, oh, print done with iteration 26 or whatever, right? And it just fills up your text output. The nice thing with this is if I just run this cell, this sleep function, just ignore it. This basically means, hey, just don't do anything for like 0.05 seconds. But it just gives us a nice progress bar. So if we have a simulation that we're running and it's taking a while, just wrap it in TQDM, run that cell, and go grab a coffee, and you can kind of see how it's going, right? And it's so simple to use as well. Look at that, TQDM, you just wrap it around whatever your iterable is. And if you want to, maybe you want to add some more things to it, you can set it to description. So if I put desk here, we can do my simulation. And if I run that, it puts it at the top. And we can have multiple for loops after each other, and all. Like if I do this, I can do something like that, where we have my simulation, and then we start my second simulation, and we start my third simulation. So pretty handy. This is a tool I only found out like at the beginning of this year, and I've been learning Python for 3 years, and the only reason I found this was because I was doing an internship, and like this was just there, and I was like, what the hell? How the hell do you get a progress bar? So that's pretty handy, small tool. Anyway, I'll let you go through this on your own time between this week and next. And I think at the bottom, We also have a 2-minute survey. If you don't mind filling that out, kind of gives us feedback to like how can we improve and what can we work on for next week as well. So a bit of live feedback. What do you want to learn with Python as well? So hopefully a bit of feedback there. We also have a bit of Easter eggs at the bottom. We won't go through that. But if you do want, you can import anti-gravity, and that will open up an KCD comic. Anyway, let's get some practice in.